Systems of equations. Again, we're going to continue to talk about other methods that we can use for solving systems of equations. Now, graphing works really well if the solution happens to be integers. It's easy to kind of hit them if the solution, the ordered pair of the solution, both of those numbers are integers. However, if those numbers are not integers, there's fractions, there's decimals, graphing isn't such a great way to do that. Or if the numbers are really large, if the numbers are in the hundreds, we don't want to make a graph that is that huge. So we're going to take a look at some other ways of finding solutions without creating a graph. And we're going to start by talking about substitution. So we've got 3 steps here as we talk about substitution, and substitution is exactly what it sounds like. We're going to take one of our equations and substitute it into the other one. So when necessary, solve at least one equation for one of the variables. We're going to substitute the resulting expression in step 1 into the other equation to replace the variable, and then we're going to solve it. Step 3, substitute the value from step 2 into the other equation and solve for the other variable. Write the solution as an ordered pair. So let's walk through those steps. First step, when necessary, solve at least one equation for one variable. So I have these 2 equations here. You'll notice that my first equation is already solved for a variable. It says y equals. So my first step is pretty much done. Y equals. Now what I'm going to do for my second step is I'm going to substitute the resulting expression from step 1 into the other equation to replace the variable. So this equation here has y by itself. So I'm going to take the y out of my second equation and substitute it with its equivalent. So y is equal to negative 4x plus 2, which means since these are equivalent to each other, I can substitute one in place of the other. So I'm going to take the y out of this expression, and I'm going to replace it with negative 4x plus 12. Now notice I put this expression in parentheses. Please put this expression in parentheses. If you need to worry about any distributive, that parenthesis will remind you that there's some distributive you need to deal with before you can solve for your variable. So what I should notice is that the equation that is remaining only has one of the variables, and that's really what we want to do when we're trying to solve for a solution for a system of equations. We want to work toward that goal of kind of eliminating one of the variables, because now I have an equation I can solve. So now I can get the x by itself. I've kind of gotten rid of the y by substituting an equivalent expression, and now I can solve for x. So here I work through my equation, and I end up coming up with x is equal to 5. Following the steps, this is the same stuff we've been doing, nothing new here. My last step, we're going to substitute the value from step 2 into either equation and solve for the other variable, write our solution as an ordered pair. So now that I figured out x is 5, remember I'm looking for an x and a y, a point on that graph, an ordered pair, that makes this system of equations true. I have x is 5, but I don't have my y value yet. So my third step is to go back to either equation. Feel free to use whichever one looks the friendliest. In this case, this first equation is pretty friendly to use. I'm going to take x out and substitute in 5. And when I do my math, I come up with y is equal to negative 8. So my ordered pair is 5, negative 8. Now again, remember that these are easy to check. So I should be able to put 5, negative 8 into both of these equations, and it should work just fine. So negative 4 times 5 gives me negative 20, plus 12 gives me 8, negative 8, check. If I put 5 and negative 8 in here, 2 times 5 is 10, 10 plus negative 8 gives me positive 2. So this ordered pair works in both. It's the solution to that system of equations. Let's try a couple more. So we have x plus 2y equals negative 3, and 3x plus 5y equals 24. So that first step, get one of the variables in one of the equations by itself. So the easiest one to work from here was to get the x by itself. If you're going to use substitution, you'll probably notice that one of the variables has a coefficient of 1, and it's pretty easy in one fell swoop to get the variable by itself. So I'm not going to try to isolate a variable in the second one, because it's going to lead to some ugly fractions. It's going to take some more work. I'm going to get this x by itself. Pretty straightforward, pretty simple to do. So I get the x by itself, and I come up with x equals negative 3 plus 2y. So I'm going to take this negative 3 plus 2y, and I'm going to substitute it into the second equation. I need to make sure I'm working with both equations, not just the same one repeatedly. I'm going to substitute that into my second equation for x, and notice that here, my y is the only remaining variable. So I solve this equation for y, I end up with y equals 3. Again, that's half of my solution. I still need to find x. I'm going to substitute y back into one of the original equations, your choice which one. If one seems friendlier, use it. and I come up with x equals 3. So my solution for this system of equation is 3, 3. Again, easy to check. 3 minus 2 times 3, so 3 minus 6 gives me negative 3. 3 times 3 is 9. 5 times 3 is 15. 9 plus 15, 24. Checks out. All right, one more. We're going to do this 2x plus 2y equals 8, and x plus y equals negative 2. So again, this second equation looks pretty easy to solve for one of my variables since I have coefficients of 1. I'm going to solve for, I just decided to solve for x. You could have solved for y just as easily. I'm going to substitute this negative 2 minus 5 into my second equation where the x is. And I come up with my y's vanish. So I end up with this negative 4 equals 8. Remember, when our variables kind of vanish and go away, we're going to see what remains. That's going to tell us it's a special solution. Either it is infinitely many solutions or no solution. Since my two sides do not equal each other, that means there's no solution. So on a graph, these two lines would be parallel to each other. There is no ordered pair where they meet. There is no point at which these two equations will be equal to each other. So substituting, solving one equation for one of the variables, substituting it into the second equation, and then coming back and finding our second variable.